Hello, in this lecture we'll focus on convergent plate boundary. We talked about divergent boundary, now we'll be able to talk about convergent plate boundary. So let's see what is the characteristic of this plate boundary. First of all, um, the convergent boundary, the plates are moving close to each other, as opposed to divergent boundary where the plates are moving away from each other. So we have divergent boundary here, the plates are moving away, but for conversion, the plates are moving towards each other. Just like in this example here, you see one plate going this way, the other one going this way. One of them, of course, will go down. We'll talk about that. So, in looking at divergent and convergent boundary, this is a divergent boundary. The plates are moving away from each other. But here, around here, we have a convergent boundary. Why? Because this plate is moving this way, and this one is going like this. The thing is that this is what we call life cycle of the sphere, meaning that whatever is gained here will be lost on this side and this side. Meaning, if let's say, for example, we have oceanic crust formed in here, let's say, for example, we have just an example, let's say 10,000 or 10 million tons of materials of crust, for example, here. Also, we should have here 10 million, this is million, 10 million tons of material will be lost here along converged boundary. And remember that the Earth, the volume of the Earth is constant. So whatever you gain here in the oceanic crust and along diverged boundary should be lost in converged boundary right here. Okay, so now let's look at this converged boundary. As I said, we have one thing that happens is that one of the plates, for example, this one here goes down and the other one stays up. So let's look at the different types of converged plate boundary. We have three types. We have here the oceanic crust colliding with the continent. That's the first one. It's called oceanic continental converged boundary because oceanic crust here is colliding with the continent. But also we have oceanic crust colliding with another oceanic crust, oceanic. And finally we have continental against continental converged boundary. So let's explore those convergent boundaries. And you can see them here in this map. You can see, for example, here, this example here, again, remember the gray is continental, white is oceanic. So here in this example right here along this boundary, we have this oceanic crust Nazca plate colliding with South American plate. So that's oceanic continental. We have also the same thing here, although this is very small, but one Juan plate is colliding against North American plate. That's the first type. The second type is oceanic. This is an example. We have this oceanic crust colliding with this oceanic crust. We have another one here, oceanic. We have another one here, oceanic. And finally, we have what we call continental plate boundaries. So we have here continent, India, colliding with a regional plate, specifically China. So that's an example of continental convergent boundary. So let's start with the first one, oceanic continental. So let's see what happened exactly here. So let's just try to use, this is oceanic crust right here, moving like this. So imagine at the beginning we have up to here, and this oceanic crust is up to here, for example. I'm sorry, this is a continental crust, I'm sorry. Let me just clear this out. So again, we have the oceanic crust. This is the oceanic crust right here, colliding with the continent, which is right here. So when these two plates collide, one of them has to go down. Which one goes down? Well, it turns out that the oceanic crust is denser. The density of the oceanic crust is about 3.0 gram per centimeter cube, but the continental crust is about 2.7 gram per centimeter cube. So which one goes down? Of course, the one that is more denser. In this case, the oceanic crust will go down like this. Now, at a certain depth, what happens is that rock starts to melt, as you can see here. So rock starts to melt, and because this molten rocks are lighter than the surrounding rocks, they start to rise. And basically this is magma, by the way. This is magma here, magma, molten rocks. So they move up to a certain level. They might stop here for a while. They might stop forever. They might probably move up, and then finally they erupt as a volcano. And that's why we have volcanoes here along the coast. This is the coastline right here, and you have volcanoes along the coastline. This is the coastline right here, and you have volcanoes along the coastline. And so these volcanic rocks here, they form a chain, a mountain, that is called continental volcanic arc. It's a little curved. That's why it's called arc, continental volcanic arc. Why continental? Because they form on the top of the continent. Why volcanic? Because these mountains are made of volcanoes. And arc because it's a little curved. Well, the type of rocks that you can find here are called andesites. And the name of the mountain, for example, in South America is called the Andes, Los Andes, the Andes, which is a typical example of this kind of plate boundary. What do you have beside these mountains? We have, of course, as we have here, we have volcanic eruptions, and also we have a trench. You can see a trench right here. This is basically a deep part of the ocean, because when this oceanic crust goes down, it causes this to curve. This curved part right here is what you call the trench. Beside these volcanoes and mountains, as you see in this example, also you have earthquakes, because this motion right here of this plate cause earthquakes right here. We have earthquake that can start here, they might start over here, but also they might start a little deeper. This is called the focus of an earthquake. If this earthquake take place, for example, happen, the waves will affect places that are close to the coast right here. But if this one right here is take place, for example, this is called, by the way, this is called shallow focus earthquake, and this one is called intermediate focus earthquake. If this one starts, it will affect rather places next to the mountain right here, for example. But if the deep focus earthquake happen, the places that are far away from the coastline will be affected right here. So we have shallow, we have intermediate, and we have deep earthquake along this zone here. Okay. So example of this oceanic continental convergent boundary, we have examples in here. We have, for example, a plate between Nazca plates right here, between Nazca plate and South American plate. So this is continent against ocean. That's a good example. Also, we have this one here, Juan de Fuca plate right here. It's very, very tiny plate, and this plate collide against North American plate, which also form mountains in here. Those mountains, those volcanic mountains, are called Cascade Mountains. Here, the collision between this oceanic crust Nazca plate with South American plate, they form mountains called Andes Mountains. And the trench right here, this deep part of the ocean right here, is called Peru-Chile Trench because it's next to Peru and Chile. We can also look at them here in this map where you can see clearly this converged boundary here with Nazca plate, which is oceanic crust colliding with the continent of South America. That's an example here. An example also here in Juan de Fuca plate colliding with North American plate. And of course, as a result, we have mountains in here, Cascade Mountains, and these mountains. So along this zone right here, we have volcanoes, we have earthquakes, and also we have mountains right here and also right here. Anytime we have this kind of converged boundary, oceanic continental, we have this activities that is volcanism, earthquakes, and mountain formation. Same map, same examples in this colored map. The other example of the converged boundary is oceanic. You can see here an oceanic plate colliding with another oceanic plate. Remember, this island here didn't exist at the time. There is no island yet. When this oceanic crust collides with another oceanic crust, one of them has to go down. Yes, we know that this has a density of 3. This one also has a density of 3. So which one goes down since they have the same density? Well, what happened is that if I draw here one oceanic crust like this, the one on the right side, this one right here, and the other one on the left side here, they collide. So let me put here the water on the top because they are covered with water on the top. Okay, and now you can see clearly now that this one here, this plate here that is longer, because it's longer, it must be also older because it has been there for a while. And if you, because it's longer, it will more likely to go down like this. And again, you can have a trench right here. Again, I'm showing you here the profile, by the way. So what happened as a result, so let me extend this a little bit here. Let me use the yellow color for this plate right here. And there's a trench right here. So when this plate right here, and there's a trench right here. So when this plate, this one here, goes down, of course, at a certain depth, you're going to have magma, just like here. When this goes down here, we have magma forming here. The rock starts to melt here, and that's exactly what happened in here. In this case right here, we have magma. The magma starts to move up, going through the cracks and faults. And finally, we have volcanoes under the ocean. And little by little, you're going to have a little mountain under the sea, which we call sea mound. Sea mound. It's a mountain under the sea. But when the lava pile up more, the material becomes above the sea level. Let me just extend the sea level right here. And when this island becomes above, when this land becomes above sea level, we have an island. And so this is the island you see here. Let me just use the eraser to take this. To remove this here. Okay, and now you can see those islands. So when this goes up, we have first volcanoes under the sea, and then finally when they have more lava, more rocks, finally we have an island. And that's what you have here, an island here, another one here, another one here, and so on and so on. And this is the example of Japan. Japan formed this way. So you have series of islands that form the island of Japan. Also, we have Tonga Island, we have Aleutian Island, and so on and so on. Those islands around the Pacific Ocean are the result of one oceanic plate colliding with another oceanic plate. And you can see, of course, the trench right here. Right here, we have a trench. And again, in this case here, we have again volcanic island arc. Volcanic because these are made of volcanoes. Island because they are surrounded by water, of course. And arc because they are a little curved, like this. Okay, so let's look at step by step of how this oceanic convergent boundary forms. So if we have some sort of weak zone here materialized by faults, then suddenly this will be split, and finally this starts to move down. Of course, as I said, the one that is usually relatively longer and older, because if it's older, it's colder, and if it's colder, it's denser. Because remember, cold stuff are older than, they are denser than warm stuff. Anyway, so the example of this are Aleutian Island right here, or Aleutian arcs. Those are islands that form like an arc. You can see them also here in this map. Those islands here on this side here, they're little small dots. Also, we have Japan right here. We have also other islands like Tonga Island, Mariana Island, and so on and so on. And of course, we have a trench. We have, for example, here Aleutian Trench. We have Mariana Trench, and so on, Tonga Trench, and so on and so on. So again, along this zone right here, when you have ocean against ocean collision, you're going to have volcanoes and earthquakes, and also formation of volcanic islands. And again, remember, if you look at all these things that are around the Pacific plate, we have all plate boundaries. And we know that along divergent boundary, we have volcanoes, and also along convergent boundary, we have volcanoes. And that's why we call this a ring of fire, because it's just like all volcanoes around because of this interaction between plate boundaries. Let's look at those islands in here. You can see them also here. We have this Aleutian Trench. This is a trench right here. This dark part right here, it's a trench. And those little part right here are islands right here. Okay, these something else. This is nothing to do with the plate boundary. It's something else. We're going to talk about this later, but it's called hotspots, like in Hawaii. We're going to talk about this later. Anyway, now the other type is called continental convergent boundary. The best example is India colliding with China. We call this plate Indian Australian plate, and we call this plate right here Eurasian plate. But anyway, remember India used to be here. If I draw again one more time, the globe, India used to be somewhere here. And India started to move all the way to Asia, where it collide with China right here. So at the beginning, we have this oceanic crust colliding with the continent, and we know that when this happens, oceanic crust goes down, it gets subducted, and finally you have volcanoes, all these things. And as if you move this, and because the land here, the oceanic crust is attached to the land of India, if this moves, this India also will be dragged along with it. So India will start to move. As a result, when India collide with China, whatever materials we have here under the ocean will be compressed, and all this here that we have here, the dirt, the sediment, they're called sediments, will be squeezed and they will form a mountain. And that's what we have here. We have the mountains. So things that are used to be under the water, they form those mountains between India on one side and China on the other side. India, again, as I said, belongs to Indian Australian plate, and China on the other side. India, again, as I said, belongs to Indian Australian plate, and China belongs to Eurasian plate. So again, this is the summary of the convergent boundaries. And of course, thing you should remember is basically the definition and the fact that the one of the plate, the spirit, the heavy one, gets subducted, means moves beneath. And here there is conception of the land because the land goes down, it becomes magma, so it gets destructed, as opposed to the divergent boundary where the land is created. The three types of convergent boundary are oceanic, continental, continental. And of course, you have volcanic arcs in here. We have continental volcanic arcs here. We have mountains here, not necessarily made of volcanoes, but they have a bunch of other rocks, including metamorphic rocks, sedimentary rocks, and so on and so on. And that would be the end for this lecture. Thank you.